Alright everybody, we're going to go over here this review sheet on probability today. Starting off with this first section for problems 1 through 5, it says find the probability of each event if a number cube is rolled. Remember, number cube is kind of like when you're playing with dice with Monopoly, things like that. It's just one of those. So you got 6 possibilities. Remember, that's going to be your denominator. The total amount of choices you have for a particular situation, that'll be your denominator when it comes to probability, and to get your numerator, it's the amount of choices that you're looking for. In other words, I say in the classroom, what choices make you happy? What is something that you want? That'll be on top. So when you roll a number cube, you have 6 choices. You have the numbers 1, 2, 3, 4, 5, and 6. So the denominator for all of these answers is going to be a 6. So we'll go ahead and put that in for all of these choices, because there's 6 possibilities. Remember, 1, 2, 3, 4, 5, and 6 are your choices when you roll a number cube. This says the probability you land on 2. So when you think of the numbers, I'm even going to write them up here to kind of help you remember them. So 1, 2, 3, 4, 5, and 6. So if you're trying to get a 2, there's only 1 2 out of a total of 6. So the denominator, excuse me, the numerator will be 1. So 1 2 out of a total of 6, that cannot be reduced, so your answer is 1/6. We come over here to number 2. This time you're looking for a number greater than 4. So you see your choices up here. The only 2 choices you have that are greater than 4 will be 5 and 6. So 2 choices make you happy out of a total of 6. You put 2 on top, 6 stays on the bottom. Reduce this down by dividing by 2 on top and bottom, and you get 1/3 for your answer there. When you look at number 3, the probability of getting something less than 1. So when you come up here and look, all these numbers are either 1 or greater than 1. So in terms of how many numbers you have that are less than 1, you have 0 choices that are less than 1. So 0 over anything is going to be 0. So your answer there is just 0. When you look at number 4, this time you're trying to roll a 3 or a 6. So you have 1 3 and 1 6. So 2 choices make you happy out of 6. That's going to be the exact same work as that one over there. So reduce it down to 1/3. And then finally over here, this time you're trying to get an even number. So you can choose the 2, the 4, the 6 and be happy. So 3 choices out of 6 would make you happy, which is reduced to 1/2 for your answer. So that's some basic probability there. Now that same mentality comes back down here with numbers 10 through 14. Before we get to that, we're going to look at 6 through 9, which is talking about outcomes. Now when I ask you to find the probability, like you did from 1 through 5, that's a fraction answer with the exception of 0 or 1. Remember, if it's 0, that means it's impossible to happen. If it's 1, that means it's certain to happen. It's definitely going to happen. Down here, when I ask for how many outcomes are possible, that's going to be a situation where you get whole number answers. So for these problems 6 through 9, there's a tree diagram. You can do that for each one of these problems, but I'm going to show you the shorter way, just to do with some basic multiplication here. So when you look at number 6, you're trying to figure out how many outcomes are possible with this scenario. So let's pretend you're at the movie theater here, and you're going to get some stuff to watch while you're just to eat while you're watching the movie. You've got 3 choices for popcorn and 3 choices for beverages there. So you got small, medium, and large. So 3 choices for popcorn times the 3 choices for beverages. And when you multiply 3 times 3, you get 9 for your answer there. So 9 possible outcomes for that scenario. The second one here, you're rolling 2 number cubes. So when you roll 2 number cubes, think about what we did for the first 5 problems. When you roll a number cube, you got 6 possible choices. So when you roll the first number cube, you've got 6 choices. When you roll the second number cube, you got another 6 choices. So you have the numbers 1, 2, 3, 4, 5, 6 on the first number cube. You have the same choices on the second number cube. So when you multiply 6 times 6, you get 36 for your outcomes. When it comes to number 7, this time we're talking about trying to make a meal here. So you've got 2 choices for the meat that you're trying to choose for the meal. So you got hamburger and chicken, so you put a 2 for that. And then you got 1, 2, 3 choices for your sides. You got fries, rice, and mashed potatoes. So 2 times 3 gives you 6 possible outcomes for that problem. And finally down here for number 9, you're tossing a quarter and then tossing a dime and then tossing a penny and see how many outcomes are possible there. So when you toss a quarter, you have 2 choices, heads or tails. When you toss a dime, it's the same 2 choices, heads or tails. Same thing for the penny, heads or tails. So when you multiply 2 times 2 times 2, you're going to get 8 for your final answer. Now remember, like I said, you could do tree diagrams for these as well, but that would take you a lot longer. Imagine doing a tree diagram for something that has 36 choices. It would be as big as this whole paper here. So this shortcut way here with just multiplying numbers might be a little bit easier for you. All right, we're going to go ahead up here to number 10 through 14. And the mentality that we use to solve 1 through 5 is going to come back into play down here for 10 through 14. Just a little bit more work we have to do for these. This time it's a probability of independent events. So you're finding the probability of each event if a coin is tossed and a number cube is rolled. So what I like to do for these problems here, rather than work out one problem and then go to the next problem, I like to get the first fraction for each problem. That just cut off, is that okay? Okay. So over here, when it comes to the probability you flip a coin and get tails, you got two choices when you flip a coin. So the first denominator for all these problems here, whether it's tails or heads, will be 2. So denominator of 2, denominator of 2, same thing over here and down here. And the reason that is because when you flip any coin, you're going to go back in and have heads as a possibility and tails as a possibility. So 2 possible choices when you flip a coin. Now the probability it lands on tails, only one of those choices is tails out of heads and tails. So it's a 1 out of 2. Same thing right here. Look at this. Probability of tails for these first problems over here. So 1/2, 1/2. Same thing on the other side. Probability you get heads. Only one side said heads out of a total of 2 sides. So therefore 1/2, 1/2 is our first fraction for these. Put your multiplying sign. So we're going to be multiplying fractions here. Now, the next thing says you're doing in this scenario is rolling a number cube. Just like 1 through 5, we got those same possible choices for the number cube. You got 6 sides. You got the numbers 1, 2, 3, 4, 5, and 6. So go ahead and put a 6 down for your denominator. So 6 possible choices. I'm going to go ahead and write those numbers up here like I did for 1 through 5 so we can clearly see what choices we have when we roll that number cube. So we're trying to land on 2 again. So remember, just like we have for the answer for number 1, which was 1, 6, because you had 1, 2 out of a total of 6, that comes back into play down here when you look at these problems. So down here you only have 1, 2 out of a total of 6, so we have 1 out of 6. So now we just multiply these fractions out here to get our final answer, and you get 1/12 for that one. When you look at this problem over here, you're trying to get an odd number, so you can choose the 1, the 3, or the 5 and be happy. So 3 choices out of 6 make you happy. Now you could reduce this down. When I was teaching this in the classroom, I would tell people to go back when they're multiplying fractions, try to find stuff they could reduce down and give them smaller numbers to work with. If you don't reduce down, it's fine. You go back and just have to reduce in the end. If you reduce this down, you could use 1/2. But we'll go ahead and just work it out without reducing it and just make sure we reduce our final answer. So here 1 times 3 is 3. And then 2 times 6 is 12. And you reduce that down by dividing by 3 on top and top and bottom to get 1/4. Over here, looking at number 12, you're trying to get a 1 or a 2. So 2 choices make you happy. So you got 1, 1 and 1, 2. So 2 of those choices out of 6 make you happy. You can reduce that down to 1/3, but if you don't want to do that, you can go ahead and multiply out. So we'll do that. We get 2 over 12, and then reduce that down to 1/6. Over here, you're trying to roll the 4, the 5, or the 6. That'll make you happy. So 1, 2, 3 choices make you happy out of a total of 6. So put 3, 6. Look, it's the exact same work we had right there. So this time I'm actually going to show you, since it's the same work. That's one way to do it. The other way would be going back and reducing. So make this 1/2 instead by dividing by 3 on top and bottom. And if you do that, make it 1/2 times 1/2, you'll go straight to the answer, which is 1/4. So either one of these ways would work. I'm just trying to show you that you can reduce it down in the problem or reduce it to the final answer and still get 1/4. And finally over here, so a lot of times people would forget when we did this one in class, they say, Mr. June, I'm struggling, I'm forgetting what this prime number means. Remember, prime number means it only has 2 factors, 1 in the number itself. So when you look at these numbers up here, the only numbers that have 2 factors, 1 in the number itself, are going to be 2, 3, and 5. So that's going to be your 3 prime numbers out of a total of 6. It's going to be, look at that, 1/2 times 3, 6. Same thing we had over here again. So you multiply out, you get 3/12, which is 1/4 again. So that's going to be probability of independent events. So what happened in the first event did not affect the second event. Now when we go over here to the back side, we're going to start to see some probability of dependent events. So what we do for the first event is going to affect the second event. So look at these instructions here. So for each letter of the word school, it's written on a card and put into a hat. So you're trying to pull 1 card out at a time. It says find each probability if you pick 2 cards without replacing the first. So you're going to pull a card, pick it out, put it to the side, and then try to pick a second card. So look right here. We have 1, 2, 3, 4, 5, 6 total cards. So you have the card with the S, the card with the C, card with the H, card with the O, card with the O, card with the L. So since you have 6 choices, your denominator for the beginning of all these fractions will be 6. Kind of like what we had for the very first problems we looked at on this paper, 1 through 5. All right, let's get these first fractions down and then worry about the second fraction. So over here, you're trying to choose an S. So you see you have 1 S out of a total of 6, so put 1 on top. I'm just going to go down the line this way, and then we'll come over here and look at this way here. So you're trying to choose an O for this one. So you've got 2 O's out of a total of 6, so put 2 on top of that one. Here I'm trying to choose an L. So you have 1 L, so put a 1 there. Go ahead and put our multiplying signs. we'll come back and finish off those second fractions here in a second. Over here with this, you're trying to choose a h, so you've got one h, so put a 1 on top. You're trying to choose a o, two o's, so put 2 on top of that. And you're trying to choose c, so you got one c, so put a 1 on top of that. We'll put our multiplying signs. So we got our first fractions. Now remember, when we try to get our second fractions, we took that card out and did not replace it. So when we take a card out, our denominator is going to go down by 1. So when we put our second fractions down, all these denominators are going to be 5 because you took a card out each time. So that's a 5. 5 there as well. 5s for these denominators. Now when we come back in and start to figure out the rest of this problem, so it says the probability we took an S out first. So I always take my pen or pencil and kind of cover up that S. So now I've got the C, the H, the O, and the L left. So we're trying to choose a C. So you have one C out of a total of 5 cards. So put your 1/5 there. So now we come back in, just multiply this out, get our answer of 1/30. I'm going to go down the line and just do these, and we'll come back and do these over here. So this time we're trying to get an L. So it says you chose an O. So remember, you choose one card at a time, so just cover up one of those O's. You're trying to get an L here. You've got one L out of a total of 5 cards left, so put a 1 on top. You could reduce this down to 1/3 and multiply out, or just go ahead and multiply out and get 2/30, which would be 1/15. That's our answer for that one. This one down here, we chose a L for our first pick. So cover up the L. Now we're trying to choose a L again. There's no L's left. You see over here, we've taken out that one, took out the one L, so we have no L's left. So 0 on top here. So this will give me 0/30, which is just 0. Now for this side over here, these a lot of times used to be the hardest questions for my students on this paper here. So it says you're trying to choose an H first, so we cover up the H, and then you want something that's not L. So as long as you choose something that's not L, you'd be okay. So you could choose the S, the C, the O, or the O and be happy. So you could not choose the L. So 4 choices make you happy out of a total of 5. Now from here we go ahead and multiply out. Now I could do reducing with the 4 and the 6, divide 2 into both of those. We'll just go ahead and multiply out and get 4/30. That's a 3 there. It's kind of messy. I'm supposed to say 30. And then come back in and reduce that down to 2/15. For this next one here, probably you chose an O, so cover up one of the O's. And you want something that's not an S. So you can choose the C, the H, this O, or this L, and you'd be happy. So that's going to be 4 out of 5 choices. So put your 4 over here. We'll multiply out and get 8/30 and reduce that down to 4/15. And last one of this section, you chose C with your first pick, so cover up the C. And now you want to choose something that's not O. So you can choose the S, the H, or the L and be happy. So 3 out of 5 make you happy. So therefore 3/30 gives me 1/10. So that's probability without replacement. So now our last 2 problems here, you see I want to go back in and just kind of show you some stuff with percents and probability and some decimals and probability. So here it says the probability of the spinner landing on red is 35%. What's the probability it will not land on red? So it's a 100% chance it's going to land on either red or not red. So if you already know the percent chance it's going to land on red, just subtract that from 100 to get your answer. So the probability it will not land on red would be 65%. So here's one with percents, and now we'll come down here and look at one with decimals to finish off. This one says the probability of rain on Monday is 8/10. The probability of rain on Tuesday is 4/10. To find the probability it's going to rain on both days. So all you can do is just kind of like what we've been doing, multiplying fractions. This time it's just multiplying decimals. So 8/10 times 4/10 would give you 32/100. So basically 8 times 4, since you have 2 digits behind the decimal, move your decimal over 2 spaces there. And that would give you your final answer for this paper here.